Hey, what's up, everybody? This is Matt from Tangible, and I just wanted to talk to you guys about some of the upcoming things we have here at Tangible, some of the stuff that we're going to be talking about and releasing. Was really excited to see the feedback on the most recent part that I posted, and just so you guys know, we're very upfront about this. Tangible posts these kind of parts for or as sales samples only, just to show what we're capable of. We don't ever intend on marketing or clearing any of these devices through. But what we're trying to do is just give people some of the ideas about what's possible, not just from a process standpoint, what we can print, but just what's possible from a design standpoint. Because I think that uh, all too often people are afraid to push the limits, especially with the new technology that they're not necessarily familiar or as familiar with. Um, so I wanted to just provide a little bit of a kind of a live look at the part in particular. You'll notice this one, I said I was going to post a video of us crushing it, so you can see here on the bottom. Um, Forget my pointer being scissors, but there's a little bit of deformation there since we pushed it past the point of yield in the test. But somebody was asking about the cell size. This is or the cell structure. This is actually a TPMS um, lattice. So it's been biased, meaning rather than kind of the more sheet-based TPMS that a lot of people are familiar with seeing, this is a skeletal or more strut-based, while still maintaining kind of the properties of TPMS lattices. So it looks more cellular than sometimes what you'd imagine a TPMS lattice looks like. So we'll go ahead and zoom in here. Um, these are actually not the bottom end of the resolution of what we could print, but it's pretty close. These are right at about 150 microns as far as the strut diameters, so pretty tiny as far as what is from a structural standpoint. But also notice that there's an extraordinarily fine surface resolution still because of the process that we use. So you're getting definitely, as you can see on some of these end plates, we have kind of an intentional noise modeled in, and that's just entirely digital, meaning we specify it digitally in the model and we print exactly what we want to specify. And then you can see there the struts now. Um, this has not been optimized at all. You do see that there are some struts kind of hang out in space. Ordinarily in a design, you want to make sure that you're accounting for and understanding, what the loading conditions are to make sure you're not going to have any pieces break off. From a particulate standpoint, I think that that's um, an important thing to definitely to consider. So just some of the things that we got coming up. So obviously this part, we want to do a little bit more of an in-depth discussion on it. So I'm going to be doing a series with Chris, um, the founder of Tangible Solutions, and we're going to be talking through some of the ideas behind why this particular cage was modeled up and some of the cool things we want to show from a testing standpoint. And then I need to get back into doing some of the computational design series that I was doing. Um, Basically, the second part of the modulo discussion, which allows you to array implicit bodies in space very easily. Then I want to go through and talk about why are fields important when you're talking about computational modeling. And then more medical in nature, discuss kind of structural strain, the strain rates, and why that matters from a biological perspective. Working on a few cool anthropology workflows. One is to kind of homogenize basically user input structure. Um, Really cool looking organic foam that sort of goes past sort of the strut-based definition of a lot of the foams out there on the market, and then also look at some of the ways we can implicitly model non-round lattice beams, since a lot of modelers out there are basically just thickening a strut with a diameter. Um, you may remember we were working on a little cervical disc replacement device that kind of is flexible in nature. So one of the things we want to do is look at some additional testing endeavors that we can do. So a partner with some test houses to investigate some of the more dynamic testing on these devices over millions and millions of cycles, which is very important when talking about, is the device going to be viable from a submission standpoint. So Tangible would like to kind of do a little bit more background research into that so that we can provide that information and confidence level to our customers that we have done our due diligence on the process and everything else that we've got going on here. So really, really looking forward to what we've got coming in the future and what we'll be able to share with you guys, and love to hear your comments or questions down below, or if you want to collaborate, obviously there's the info down below. You can reach out to me or info@tangiblesolutionsdom3d.com. Thanks, guys.